Okay, so question 5, the final question. Right. On the 7th of June 2017, more than 50% of the energy generated in the UK was from renewable sources. Suggest 2 environmental conditions in the UK on the 7th of June 2017. Renewable sources. So, to be honest, bit of a weird question. It does say it's high demand in the spec. But what renewable sources do we know? We know, hopefully, about solar panels. Okay, solar panels, you've got wind turbines. Terrible drawing of wind turbine. What else have we got? We've got geothermal, we've got something else. Geothermal. Oh yeah, you've got dams, hydroelectric, tidal, all those types of things. So, but they're asking for environmental conditions in the UK on the 7th of June. Well, I know it's sunny, so it's summertime, right? So, high light intensity. Okay, so not much cloud, maybe. Okay, high light intensity and maybe low cloud cover. Cloud cover. Okay, the mark scheme does say wind turbine, but I'm not sure how you're supposed to guess that from what you're given. Okay, let's have a look. At midday, 35.4 gigawatts of electricity was generated. Lillian, can you be quiet, please? Or not shout? Right. 35.4 gigawatts was generated. Giga is times 10 to the 9. 10 to the power of 9. That's a big number. 20.8% of this was provided by gas-fired power plants. Calculate the energy per second that was provided by gas-fired power stations. Well, this is watts, so it's 10 to the 9 joules per second. Okay? So I just need to get 20.8% of that value and express it in joules. Right. 20.8 out of 100 is expressing it as a fraction. 20.8 of 100 is 20.8%. Times that by 35.4 times 10 to the 9. Okay. If I had 50% of something, it's the same as multiplying something by 0.5, okay, and 50 divided by 100 is equal to 0.5. So that is essentially what I've done here, this bit here, and then I'm taking that as getting the percentage of that 35.4. So just to show you how I'm putting this in the calculator, 35.4 to the power of 9. I use the exp button down here on this calculator to get 35.4 to the power of 9 multiplied by 0.208. Okay, and that gets me a very, very large number. Okay, but they're forcing me to express it this way because they're giving me the unit joules. So it's going to come out as 73632 and then 5 zeros, 1, 2, 3, 4, 5. Okay, I personally would have been wanting to express that as maybe 7 gigajoules or something like that. Yeah, 7.3 gigajoules times 10 to the 9, you can see, hopefully. Okay. Some of the electricity generation was from low carbon sources. Low carbon sources emit very little carbon dioxide. Name one non-renewable source that is a low carbon source. Okay, non-renewable. So these are things that get used up. Okay, so nuclear power, that's one that gets used up. Uranium gets used up. We have a finite amount of it. And it emits barely any carbon dioxide because the energy is coming from nuclear reactions, not chemical reactions. So I'm going to put down nuclear. Right. In the UK, electricity is delivered to customers by the national grid. Explain the main features of the national grid. So, the national grid, you've got a power station. Hopefully they're not all coal-fired, not anymore. The power station connects to a step-up transformer, step up, and then that goes to transmission cables. These are the pylons to go across the country, and it comes back down again, goes to a step-down transformer, and then it goes to people's homes. So what are the main features? 6 marks. We've got to talk about this whole system basically. This kind of, I suppose, this bit here is the grid. Okay, so I would start by saying, I'm not going to write out an answer to this because my handwriting's so terrible anyway, but I would start by talking about step-up transformers. I would say, first of all, a power station, either conventional or a renewable source, is used to generate electricity. This electricity is then sent to a step-up transformer where the voltage is increased and the current is decreased to improve the efficiency of transmission. Okay, the high voltage supply is then transmitted along pylons and transmission cables across the nation, and then when you get closer to residential areas, housing, etc., you have a step-down transformer to bring the voltage back down to something safer. Correspondingly, the current is jumped back up again. In order to step voltage up and down, we use transformers. Okay, so hopefully I've hit all 6 marking points there, but we'll check the mark scheme in a second. Okay, this is the last question. So the national grid supplied a house with 18,000 or 18 million joules of energy in 1 hour. What was the average current supplied to the house during that hour? Write any equations that you use. 5 marks, right, so quite a challenge. So I'm going to just think, what are the formulas that might be useful? Well, definitely the power equation, power PIV, power equals current times voltage, that might be useful. Power is equal to energy divided by time as well. Okay. Right, I think that's actually enough. Something else I'll need to know. I'll need to know the voltage in the UK. The voltage in the UK is 230 volts. Used to be 240, it's 230 now. Right. First I need to work out the power that the house was using. Okay, so power is energy divided by time. The energy, P equals energy over time. The power is going to be 18,000 divided by, I need the number of seconds in 1 hour. Well, if you've watched this video all the way through, you'll have seen me working this out before. 60 times 60, 60 minutes in 1 hour. Each minute has 60 seconds in it, and this will give me a value for the power. So 18123. That's the energy. The time, 3600 seconds. So the power is 5,000 watts. 5,000 watts. Okay? Cat, shut up. 5,000 watts. So now I have this value, and I need that value. Okay, so P equals IV. Rearrange for I, divide both sides by V. Again, if you want this in a triangle, P's on top, IV on the bottom. You're trying to get I, so cover I. It's P over V. So I'm going to do P divided by V. P divided by V, power 5,000 divided by 230, which is something you need to know from memory. 5,000 divided by 230. 21.7 amps. 21.7 amps. Okay, so we'll check the mark scheme and see how we did there. Am I crushing you, cat, or something? Okay, so let's have a look. Little cloud cover, favourable wind speed. I don't know how you were supposed to know that the wind speed was favourable in the UK in June 2017. But they did give you a few clues, and it is a specimen paper, so I'm not expecting it to be perfect. Right. They accept the answer in standard form, so I could have written 7.4 times 10 to the 9. They allow you to write it like this. It does make more sense to write it in standard form. Okay. The points made about the national grid. You've got step-up transformer, you've got step-down transformer, mentions about the safety, mentions about decreasing current for more efficient energy transfer. I didn't mention the heating effect of a current, but that is one of the points. And the final question, 5 marks for this mega calculation. Okay, you do have to calculate the power, which is 5,000 watts, using the energy supplied and the time for 1 hour, which is 3,600 seconds. That gets you the power. Then you're using it with P of power equals current times voltage, rearranged for I. And you have to remember that the voltage in the UK is 230 volts. So I put 21.7, but it's saying allow an answer that rounds to 22 amps. Okay, I hope you found this useful. Thanks for watching, and shall we just get this cat one last time? Shut up! You're interrupting. If you've enjoyed this video as much as the cat has, please comment, like, subscribe, and share. Thanks for watching.